Okay, welcome to your DSA review. Let's get through this. This is a 10-question review, and each question has one part where I'll go through it, and then the second part, you'll go through it and answer. All of these are questions that should have already previously been seen, either in class or while you're working through your Goal 1 topics. So the first question we have says plot 12, 4, and -7 on the number line. So let's pull out some drawing tools here and do so. So if I'm looking for positive 12, I've got to go to the positive side of the number line, and that's going to be 2 spaces to the right of 10 in our counting numbers. For positive 4, that's going to be 4 spaces to the right of 0, because it's also positive. And then we have a -7. Negative numbers are always to the left of 0, so that will be 7 spaces to the left of 0. Now keep in mind, I said where all of the numbers are in relation to 0. Positive 4 is 4 spaces to the right. Positive 12 is 12 spaces to the right. And -7 is 7 spaces to the left. Now, what I would like you to do here is take into account where each number is in relation to 0. Is it to the left of 0 because it's negative? Is it to the right of 0 because it's positive? And you're going to fill in where is each of these values, -9, 3, and -7, in relation to 0 on a number line. All right, for our next question, it says use the less than, greater than, or equal to symbols to compare the following numbers. Down below, I've provided a number line, and even though it is partially cut off, we still know what numbers are here. For counting by ones, which we can see this number line is clearly increasing by a scale of 1. I can see here that I have -7, -8, -9, and -10. And the number line never actually ends. It just gets cut off because you can only fit but so much on a given sheet of paper or screen or whatever have you. Okay, so this number line does infinitely continue to the left and to the right of each side. Okay, so let's start by comparing -2 and -11. So here is -2. And -11 would be to the left of -10. Now, the numbers on the right are always greater than the numbers to their left, okay? When you go to the right, that is increasing. And the contrast is also true when you go to the left, that is decreasing. Therefore, if we're going towards the right, then -2 is in fact greater than -11. So I'm going to make it greater by putting that symbol like so. -2 is greater. And the greater part always eats the larger number. Okay, now we're comparing -7 and -6. So here's -7, here's -6. -6 is on the right, so -6 is greater. That's it. Let's switch colors for the very last one. We're going to look at -8 and +10. So here is -8. And here is +10 down here. Now, other than the obvious of a positive number always being greater than a negative number, it still holds true that the number to the right, -10, is always greater than the number to its left. So, not -10, +10. So, +10 is greater. So I really want to emphasize in the very first one that we looked at, -2 compared to -11, we have that down here in red. -2 is to the right of -11, therefore -2 is greater. For -7 compared to -6, -6 is to the right of -7, therefore -6 is greater. For -8 compared to -10, for -8 compared to 10, 10 is to the right of negative 8, therefore 10 is greater. The number to the right is always greater than the number to its left. The number to the right is always greater. Okay, now I'm going to give you guys a moment to pause here and answer these questions. If you need some support, use a number line. Okay, you can just Google one. That's it. Google it or make one. So, for example, if you needed that support, you can just draw a line. As you can see, my line's not perfect, and I'm going to leave it not perfect because I want you to understand that your line doesn't need to be perfect either. I can see my smallest number is negative 10, so I'm going to put that over here. And then you're just going to count back to get all of the numbers in between. You know, my negative 8 came out sloppy, but you get the idea, okay? And you won't run out of space because you'll be writing this on paper. So you just keep on going and going and going if you want, adding more sheets of paper. But yes, just make and use a number line. It's a simple skill that anybody can use, so there's no excuses in getting this wrong, especially if you are given tools like, hey, just make a number line or Google a number line to help you, okay? Okay, next question up. Find the distance between A and B on the number line below. So I see A is plotted over here at negative 11 and B is plotted here at negative 1. Now visually it's very easy to work through this because I can say here's A, and if I'm walking from A to B, because that's what distance is really calculating. It's calculating the steps, and we measure steps sometimes literally just in how many steps. Sometimes we measure steps in miles, in kilometers, in meters, and so forth. So what's the distance? How many steps are we going to take here? Well, we're going to take 1. That would count as 1 step because you just moved from negative 11 to negative 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10 steps. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So visually we can see the distance here is 10. Now, if you're not sure about visual, you can take the absolute value of negative 11 minus 1 to find the distance in between. And that gives you, negative 10, which is still 10. Or you can just count the steps. So there's 2 strategies here. There's this strategy and there's this strategy. Now this is nice because you can visually see what's occurring. However, as you move into algebra, this is what you need to be comfortable with. Now I want you to try, okay? Find the distance between G and H, where G is at negative 2 and H is at 7. I showed you 2 strategies. Remember, visually, you can literally count the steps, okay? Okay, next question. Write a fraction or a mixed number for your answer. So we're told to write a fraction or a mixed number. And I can see that C is plotted somewhere in between 1 and 2. If I'm making an estimate, I would say it's pretty close to 2. This value is much closer to 2 than it is to 1. But I don't know how many parts it's being broken up into. So let's actually see if we can model this out. If we were starting over here, if I was going to 1, I'd have to take 1, 2, 3, 4, 5, 6. So therefore, this is 1 out of the 6 steps to get to the next hole. This is 2 out of the 6 steps. This is 3 out of the 6 steps. This is 4 out of the 6 steps. This is 5 out of the 6 steps. And 6 out of 6 steps gets me to the next one. So if we're still counting by that same unit of measure, I'm just going to change colors here. If I'm going from 1 to the next whole, from here, 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 I can see that right here I have 1 and 1/6 now. Now I have 1 and 2/6. I'm running out of space. I'm going to put this down below. 1 and 3/6. 1 and 4/6. And here at C, we have 1 and 5 out of the 6. So I had to count how many spaces this was being broken up into. I looked, if I was at 0, I'd have to take 1, 2, 3, 4, 5, 6 steps to get to the next hole. So this is broken up into 6 parts. Okay, so this is still being broken up into 6 parts. 1, 2, 3, 4, 5, 6 steps to get to the next hole. So 1 and 5/6. And I want to emphasize it's 1 and 5/6 because we're past 1 on the number line. Okay, so therefore, like if I was right here, this would be 2 and 1/6, 2/6, 3/6, which could actually be reduced to 2.5. All right, now you give it a shot. Okay, I encourage you to look at how many parts this is being broken up into, just to make this a little bit visually more accommodating for you. I'm not going to put the numbers in, but I will make the spaces a little bit more obvious. Okay? And to be clear, find the position of E on this number line is the task that you have. Find the position of E on this number line is the task that you have. Okay, so now we have plot 2 and 4/5 and 1 and 7/10. Now I'm looking at this and I can see that our denominators are breaking this up into 2 separate sections, or 2 types of sections. I'm just going to move this a little out of the way. Okay, so 1, this fraction is being broken up into fifths. So if I were to go by fifths, and then the 1 over here is being broken up into tenths. Now, as I look at my number line, I see that this is clearly not being broken up into 5 parts, but it's definitely being broken up into 10 parts. So I'm actually going to start with this one, right? So if I'm doing 1 and 7/10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10 steps so I get to the next number. So if I'm looking for 1 and 7/10, here's my 1. And for 7/10, I've got to go 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. And right there is 1 and 7/10. Now to plot 2 and 4/5, to plot that number right there, let's just make sure we can really see that fifths part, right? That's what we're looking for. I'm going to have to go ahead and break this up into fifths. Now, what's nice is that these numbers are multiples of each other, 5 and 10. In fact, if I divide 10 by 2, I get to 5. So that's exactly what I'm going to do. Instead of counting by 1s, I'm going to count by 2s, so I can break that up into 5 parts. So let's change colors for the different one. Okay, so if I'm doing fifths now, and this is evenly broken up, all right? Each segment has exactly 2 in it when I break this up into fifths. So for 4/5, I have, here's 2. So we know we're going to be in between 2 and 3 because this is 2 and 4/5. So here's 2 and 1/5, 2/5, 3/5, 4/5. Right here is 2 and 4/5, which is also the same as having 2 and 8/10. And now it's your turn to try. To make this more visually appealing, I am going to go ahead and put some spaces in between. So if we're looking at ninths, I can see that this would be 1, 2, 3, 4, 5, 6, 7, 8 ninths. And if we're looking, let's change up the colors, at thirds, 9 divided by 3 is equal to 3. So breaking this up into thirds would be 1, 2, 3. 1, 2, 3. And ninths, okay, good luck. Okay, so it says order these fractions from least to greatest. So let's visually see the difference of what we're working with here. Now, I thought about actually using the computer to draw like a perfect rectangle to model these rectangles. And I chose not to because chances are when you do this by hand, yours won't be perfect. And I want to emphasize that it does not have to be perfect in order for it to work. Okay. So in this bar here, I'm going to put 2/3. So that means I need to have 3 parts. Okay. Now I'm going to try and make the next one the same as much as possible. And this one's going to be 6. And then I have 2/4. I'm also going to make this one the same as much as possible. Okay, now if I'm shading these in to do 2/3, there's my 2/3. For 2/6, there's my 2/6. And for 2/4, there is my 2/4. Okay, so I'm actually going to show you guys 2 strategies. This is the first of the 2 strategies. So this would be 2/3. We can see that 2/3 is in fact the largest here. So this would actually go here. Visually, we can see that. We can also see that our fraction 2/6 over here is the smallest. And common sense or trial and error should that therefore tell us that 2/4 is the middle one. Now, what if you can't visually see that, right? What if these two look pretty close to each other? And because they are relatively close, then my recommendation would be to divide, okay? Divide 2 divided by 3 because 2 divided by 3 is about 66%. So that'll give you a 0.66 repeating. 2/4 is equal to a half, so that's 50, right? If we're thinking about money, it's 50 cents or something. And 2/3, that's another repeating decimal, that is 0.33 repeating. So now we can see why 0.33 is definitely less than 0.50 and definitely less than 0.66. So we can also see if we just divide each fraction, 2 divided by 6, 2 divided by 4, and 2 divided by 3, you can see that 0.66 is clearly the largest, and this fraction that it's equivalent to is therefore the largest. So that's two strategies that you can use, okay? You can either do strategy 2, which I said was to just divide, or you can visually draw a model and see that. Just make sure that you're making them all as close as possible, but you can see that the fraction bar that is 2/3 is larger than the others, and that 2/6 is clearly smaller than the others. Okay. Okay. Now it's your turn. You're going to order these fractions from least to greatest. To make it a little bit easier for you, I have already drawn out 3 models for thirds, fourths, and eighths for you to compare. Okay, this next segment says, what is the location of F on the decimal number line below? Write your answer as a decimal. So one of the key things that you need, or that's being emphasized here, is that we've got to be able to write in decimal form. All right, it says it's a decimal number line, and we've got to write in decimal form. So hold on, let me just move this out of the way. Okay, so looking at this, I'm going to look at how many parts this is being broken up into. All right, this is going, in fact, let me just start over here to see how many steps. 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. And this is beautiful because tenths are amazing to count by. So if we're at 2, this would therefore be 2.1, or 2 1/10, 2 2/10, 2 3/10, 2 4/10, 2 5/10, 2 5/10 in decimal form. All right, in decimal form, there's 2 5/10. Now it is your turn to find the location of B on this number line. Okay, to continue on, it says order these numbers from least to greatest. So as you can see, I've already partitioned some lines over here for me to line up my numbers and see where everything falls. So the first number I have is 9 and 309 thousandths. So 9 and 309 thousandths. I have 9 and 35 hundredths. I have 9 and 5/10, and I have 9 and 2052 10,000ths. Now looking for the least number over here, right? That's where the smallest number's got to go. This is clearly the smallest number. I can't click and drag this, but I'll just write it over here. This is where, in fact, actually, I think I can do a little bit better than that. 9,000, or 9 and, 2052 goes there. Now for my next smallest, I'm debating between this one and this one. Now, what you can't see is that you can actually kind of cover these up to see. So you've got 9.3 and 9.3, 9.30, 9.35. 9.30 is less than 9.35, so therefore 9 and 309 thousandths, this number here, is less than 9 and 35 hundredths. Okay, so 9.30 is less than 9.35. So 9.30 9.309 comes here, and 9.35 comes here. And clearly 9 and 5/10 is therefore the last number. Okay, so my recommendation is you can line up all of those numbers. We're just putting 0 placeholders there. It doesn't change the value of anything. You can line up all of your numbers on a set of paper, and then go row by row, or column by column, and see which one is greater than or less than. And now I want you to try to do the same for yourself here. Okay, here we are told to find KM and MJ. So we're going to find the length of KM and the length of MJ. So for KM, that's this segment here. So to find this distance, the most obvious way is to just subtract 17.8 from 9.2, or 9.2 from 17.8, and see what the distance in between these 2 points are. So for 17.8 minus 9.2, that would be a different distance of 8.6 units. Now for the distance of MJ, let's do this one in a different color. Here's the distance of MJ all the way down here. I've got to take into account that I am crossing over 0. Okay, I'm crossing over 0. However, if we're finding distance, it is impossible. It is physically impossible to walk or move in a negative distance. You might move forward, you might move backwards, but you're still moving, and therefore it is still positive. You cannot undo a walk. So if I'm going from J to M, I have to take 4 steps just to get to 0, plus the distance from 0 to 17.8. So I have 4 plus 17.8, or 17 and 8/10, which is 21.8. And this one over here should be 8.6. Okay, now it's your turn. Find the distance of yx and yz. And just to emphasize the locations that we're looking at, for yx, you need to take into account that you will be crossing over 0 on your distance. And for yz, I believe you will also be crossing over 0. For yz, what letter is this? That's X. Okay. For yz, you will not be crossing over. Yz's right there. Okay, so you'll be looking at the distance from here to here. So this is y, just to emphasize. This is z, and you can see x right there. Find the distance. Okay, last question. Jessica is riding in a bike race that goes through a valley and nearby mountain range. The table gives the altitudes in feet above sea level for 5 checkpoints in the race. Use the table to answer the questions. Just always read it again. Jessica is riding in a bike race that goes through a valley in nearby mountain range. The table gives the altitudes, the feet in feet above sea level, for 5 checkpoints in the race. So here are the 5 checkpoints. Here's the altitude, meaning how high above or below sea level the surfaces. Compare the altitudes of checkpoint 3 and checkpoint 4. So checkpoint 3 and checkpoint 4. And as you can see, I added this number line. This number line was not already here. I added this as a visual. So that being said, that is a strategy that you can use is get a number line. Google it. Okay, it's that simple. Just look one up. Okay, so for checkpoint 3 compared to checkpoint 4, checkpoint 3 I can see is at negative 183, and I don't have the exact location, but that would be kind of close to negative 200. So I'll put it right there. There's almost put C. Actually, I don't want to use the number 3 right there, so I'm going to get rid of that. So there's checkpoint 3. And checkpoint 4 is at negative 29, so that's in between 0 and negative 100. And just as we mentioned before, the numbers on the right are greater than the numbers to the left. So this is estimatedly where negative 29 is going to fall, in between 0 and negative 100. And this is where negative 183 is going to fall. So I can see that negative 29 is in fact greater than negative 183. So I'm going to use my greater than symbol there. Then it says, what is the meaning of the inequality above? Checkpoint 3 is higher than checkpoint 4? Yes, it is. Checkpoint, oh, no, it is not. So I got to reread stuff. This is checkpoint 4, negative 2, negative 29. And this is checkpoint 3, negative 183. So checkpoint 3 is lower than that. So that is actually lower. So checkpoint 3, checkpoint 3, checkpoint 4. Okay, next one. Let's use a different color. Compare these altitudes. Okay, well, one's positive and one's negative, so the positive one's always greater. That's a no-brainer. But we'll look at this on the number line as well. So we have 1,237. So that would be about right in there. 1,237. And negative 114. That would be in between negative 100 and negative 200. So about right there. Negative 114. Okay, what is the meaning of the inequality above? So let's make sure we're not making any careless mistakes. Checkpoint 2 is higher than checkpoint 5. Yes, it is. Checkpoint 2 right here is higher because it's close, it's more positive than checkpoint 5. So now you guys are going to try this on your own on the next slide. Okay, so here's your next question. I added the number line to this slide to help support you with your answer. Remember, on the actual test, you're welcome to use your own number line to help yourselves.